Before we get started with the course, let's talk about what a rectifier is and how it works. So in simple terms, a rectifier is a device that takes electrical energy in the form of alternating current and converts it into direct current. So let's say that we have a voltage source, let's call it Vn. And so we're going to feed that into some device, and we'll just draw a black box for now. But in the course, we're going to see the different types of circuits that would go in this black box. So then this device outputs the voltage in direct current form. So we're going to say that we have a voltage V out, and let's also define the current. So we'll have I in, the input current, and the output current, let's call it I out. So inside this yellow box, basically we would have different types of circuits that can perform this function, so that they can convert electrical energy from alternating current form into direct current form. And so a typical symbol for a rectifier is like this. You have a box, and then at the input you have a sine wave drawn, and at the output you have a DC voltage. So this symbol right here is a symbol for alternating current, and this symbol right here is a symbol for direct current. So now let's get a little bit more specific. So let's draw the input voltage and the output voltage in a pair of axes to see how the circuit works. So again, the input voltage would be a sinusoid in most cases. So it would look, let's say, like this. This being of the form Vs sine omega t. So this is a sine wave, and let's say that this waveform has a peak magnitude of V. So then what we would want from an ideal rectifier is an output that is of the same magnitude as the peak of the input voltage, but it's a flat DC voltage, so it's a flat direct current voltage. So if we say that the input has a peak magnitude of V, then the output would also have a magnitude of V, but it would be flat. So this is what's normally called as alternating current, or AC voltage. And this is what's commonly referred to as direct current, or DC voltage. And so notice that the output is perfectly flat, and in practical applications this isn't the case. Normally you would have what's called some ripple at the output. So ripple is if this output voltage, instead of being a flat voltage, if it was something more that looks like this, then the ripple of the output voltage would be from here to here. Now for an ideal rectifier, this ripple is 0 volts. So in other words, the output is perfectly flat. And this ripple is sometimes defined in terms of the peak-to-peak voltage. So what that tells us is the difference between the maximum of the output voltage and the minimum of the output voltage. And so let's say that the output voltage, if it's fluctuating between 10 volts and 20 volts, then the ripple would be 10 volts peak to peak. However, for an ideal rectifier, because the output is perfectly flat, then the peak to peak voltage is 0 volts. Now we can say the same for the current. So if we have a current that looks like this, so it's a sinusoid slightly delayed from the input voltage, for example, and has a peak magnitude of I, then we would want the output current to also be a flat DC current with a peak magnitude of I. So let's go ahead and define a few characteristics of an ideal rectifier. So we can say that V out peak to peak, which would tell us the ripple at the output, is 0 volts. Also I out peak to peak, which again will tell us the ripple of the output current would be 0 amps. And one more important characteristic would be that we would want the input power to be equal to the output power. So in other words, there's no power loss in the rectifier circuit itself. Now you may be wondering, why would you want to convert alternating current into direct current? And the reason is very simple. Most electronic equipment use direct current voltage instead of alternating current, but most power supplies are in the form of alternating current. So let's say, for example, that you're trying to use a computer at your house, and the power outlets in most houses are in the form of alternating current. So you would want to have some means of converting the energy from alternating current at the power outlet in your house into direct current such that the computer can use it. So that's why rectifier circuits are very common in power electronics, and almost any power supply that is used to power an electronic equipment has a rectifier in it. Now, this rectifier that we've been discussing is what's called a single-phase input rectifier. However, rectifiers can also be of the three-phase type, so you can have a three-phase input and have the same DC output. So let's go ahead and draw that. So you can have three inputs. Let's call it VA, VB, and VC. And typically these are three sine waves delayed by 120 degrees apart. So they will look like this. Now, if we say that the three-phase input voltages have a peak magnitude of V, for a three-phase rectifier, the output voltage doesn't necessarily have a peak magnitude of V as well. And we're going to see why in the next couple of lectures. But what's important is that it is also a flat DC voltage. So the output voltage would look like this. And the output current would also be flat. And the same characteristics as for the single-phase ideal rectifier apply. So the peak-to-peak output voltage is 0 volts. The peak-to-peak output current is 0 amps, and the input power is also equal to the output power. So now that we've looked at what an ideal rectifier is, let's take a look at what goes inside the black box. So we'll take a look at the different types of circuits that we can use to make a single-phase rectifier or a three-phase rectifier, and we're going to see how they compare to each other. There are many different types of rectifiers, and we'll analyze a few of them.